Thank you. Hello, everyone. My name is Wei Gai, a PhD student of Shandong University, China. I'm thrilled to have the opportunity to deliver the presentation. My co-authors, Chenglei and Shen, are also here in the audience. I will present our work of the paper titled Supporting Easy Physical to Virtual Creation of Mobile VR Maze Games, a new genre. Our new genre follows these three guidelines: easy design, natural play, and multiple modes. I will divide my talk into four main parts. First, I will introduce the background and the motivation of our work. Virtual reality is obviously popular now. There are various games and devices for VR, such as Facebook Oculus, HTC Vive, and Google Cardboard. The introduction of Google Cardboard demonstrated the possibility that a smartphone can be turned into a VR machine with the help of height-mounted display, HMD. Especially nowadays, the smartphone has become popular, which really takes VR to the masses. So the question is, when you enjoy most of the VR games, have you ever thought about that? How to make a mobile VR game by yourself? At present, there are many softwares for designing a VR game, such as Unity and Unreal. And the current mainstream VR devices have provided Software Development Kit, SDK. Although there are many ways for designing a VR game, the design process is not accessible to the players in most VR games. So, based on the motivation, we proposed a new genre, allowing players to play what they design with optimal experience. And what's the innovation of the genre? It's accessible for players to participate in the design process of a VR game. In the new genre, the designer is the player is the designer. Designers and players are the same. Moreover, players may express their creativity and enjoy the creation. The video will briefly introduce our game system. Let me show you.
A new VR game genre allows laypersons to design games in a physical space and then play them in a VR environment, enabling fluid and rapid iterative design and execution. It does not require any specialized room, expensive equipment or training, and can be played at any time.
Okay. Next is our system design and implementation. For the first step of exploring in this direction, we developed a mobile VR maze game system. The system is composed of a mobile HMD, a portable Kinect device. Based on the mobile power, it can be adopted as a no-keyboard device to use in places without power. And how does it work? As you can see, the system has three parts: design in the physical world, convert on the mobile phone, and play the game that you have designed. First, let's talk about the design. We aim at developing a simple and participatory creative platform to support general players building the virtual world. A big canvas in the physical world is provided for users to create different kinds of mazes in the physical world. With the use of low-cost everyday tools such as chalks and color boards, the markers on the ground represent the worlds in the virtual world. The concept of authoring levels for a virtual game is proposed, and that is easy and convenient for general users. Then we developed software for computing the geometry information of the physical maze to reconstruct the corresponding virtual maze based on Android Studio. It includes 4 steps. Step 1. Takes a picture of the physical maze using smartphone camera. The angle of camera is not restricted, as long as the 4 vertices of the physical maze are included. Step 2. Calibrate the picture of the maze. Select the 4 vertices on the boundary of the maze, and then the calibration will be done automatically. Step 3. Recognize structure information of the maze, and Step 4. Store this information of the maze in a file. So far, we have computed the structure information of the physical maze. Then, we developed a software to allow users to play the game that they have designed based on Unity 3D. A mobile HMD and Kinect sensor are used to track users' orientation and position, to control users' point of view and allow natural interactions with the virtual world. We provide 2-player modes, single-player mode, and multiplayer mode. In single-player mode, although there is only one who can interact with the virtual world, others can view the trajectories of the player and the structure of the maze. This is a way to join in the game for users without 3D glasses. For example, when the child is going to hit the wall, his parents will remind him by the blackboard on the floor. This is a flowchart of single-player mode. In the multiplayer mode, players can play in a physical room, and they can also play in different rooms. Additionally, we provide a new design mode. When one player is playing the game, the virtual objects can be dropped into the game space by another player in real time. This is another way to join in the game for users without 3D glasses. Compared with placing virtual objects in advance, dropping in virtual objects in real time is full of challenge, surprise, and unknown experiences. To verify the effectiveness and usability of this game, we have conducted a user study. It includes 3 experiments. Experiment 1 is designed to test our system usability and the effect of different interactive modes on user experience. Experiment 2 and 3 are designed to test the value of different design modes and player modes. The interactive modes include 3 different conditions. Number 1, the user sit and interact with a monitor, keyboard, and mouse. Number 2, the user sit and interact with HMD and gamepad. Number 3, the users walk in the physical space and interact with HMD and Kinect. The design modes include add objects before or when playing the game. The player modes include single player and multiplayer mode. For the user study, there are 61 Chinese students participating in the study. This is the user study procedure. I would like to point out that before the user is asking to use different interactive modes, we take a 5 minutes baseline to measure physiological flow. Similar to experiment 1, the users completed experiment 2 and 3. The measures we used are first simple usability, system usability, 9 items measuring system quality and information quality are taken from the 3rd edition of Post-Study System Usability Questionnaire. Second, flow experience. Flow is a state in which an individual is fully immersed and engaged in the process of activity, and it is a key component of users' experience in VR. The most common methods to measure flow experience are questionnaires and interviews. In this study, the flow is measured with flow shot scale. To distinguish which interactive mode will bring better flow experience, we measured these 3 values: electrode mode activity, heart rate, and respiratory depth. After every experiment, we also set 1 or 2 questions to investigate users' preference to different modes. Last, we measured additional experience for design modes. The results of our user study. First, system usability. You can see our system has a high system usability because the scores of our system are all higher than the reference scores, the red line, and most users prefer to our system, suggesting that our system is consistent with players' needs. Second, the results of interactive mode. It shows that by moving around a space leads to higher flow results, and that makes it to be more preferred than non-moving modes. You can see the red one. From the aspect of physiological flow experience, results show that by moving around a space also leads to higher flow results than non-moving modes. These results improved our confidence in the moving around mode and motivated us to further develop the system. Last, player mode. Results show that users are more excited in the multiplayer mode. You can see the red one. But there are about 38% users liking the single-player mode. It is not a small proportion. This suggests that it is important to develop both of these player modes. In this paper, we present a novel mobile VR game genre for general users. Based on this genre, we developed a maze game system that enables users first design in the physical world and then play in the virtual world. The main innovation of our system is that it is accessible for users to participate in the design process of a VR game. The design platform is fast, flexible, and creative, and it can also provide natural interactive ways and multiple game modes to reach the user's experience. Our user study also shows that such a system has the possibilities to foster an active participation and provide a richer, more interactive, and engaging experience. Additionally, we are working to apply our system in a range of applications. There are some examples using our system. This is a museum layout. When a user is wandering in the virtual museum, she can talk about the layout of the museum with her friends. Her friend can put cultural objects in the specific position in real time. Another one is a firefighter simulation system. The user needs to look for the burning objects in the virtual world and put out the fire using the simulation water gun. It's conducive to the popularity of firefighting knowledge. Then our ongoing and future work are We are working on to design a new tracking method between multiplayer occlusion. Because multiplayers may occlude each other in the game space, and we plan to propose a universal lightweight method for tracking in VR. I will introduce our recent research. We plan to optimize and deeper develop it in the future research. Considering my spoken English, there might be places that I didn't explain clearly. So you are welcome to send an email to the following address. I would be glad to communicate with you. That's all about my presentation today. Thank you for your listening.
Hi, I really
Hi.
liked your talk. I'm Nella Rourke from Northwestern University. I was wondering if you could talk a little bit about the types of things that people built, so the types of mazes, if anything kind of unexpected happened, or if that made you think differently about the types of applications that you might use this for in the future.
Sorry, can you say it
Yeah.
slowly?
Sorry.
Slow. Yeah.
What types of mazes did people make? And do you have any things you wanted to share about what people built?
You see the type of the maze? Yeah. In this paper, we are the first setup of exploring in this direction. We just developed a maze game system. Yeah, a maze game. And the users can connect to the Wi-Fi. They can share the same ways. Yeah.
Great,
Yes.
thank you.
Thank you. Okay.
Had you thought about authoring other parts of the game with physical objects, like the virtual objects, things other than the maze walls? So the maze walls are authored with physical objects. Have you thought about authoring other parts of the game with physical objects as well?
In the paper, we provide canvas in the physical world that can be captured by the kinetic sensor. You can design the maze in this area, and you can use the low-cost everyday tools. The tools can represent the walls in the virtual world. Is it the answer?
Well, the player can add virtual objects. Could they do that with physical objects as well? Like author the virtual objects?
You see, add the object in, we can add virtual object in the maze. For the users without 3D glasses, yeah, the objects are now virtual. Yeah.
Okay, thank you.
Thank you.